Good afternoon. This is Dr. Eidelberg, and this presentation will deal with project definition, overview, and some of the project management principles. So we are in Module 12, and we'll go over here to Module 12 reference material. We'll click on process specifications, which is our title for the presentation. The topics that we will cover will relate to the final project objectives. The final project in this course have the objective of simulating a competitive industrial process development. We will learn the basic project management tools and phases such as initiation, planning, execution, and completion. We will also practice teamwork, establishing 4 competing corporations. Each will include 4 engineers, which is related to the role on which they're seated. We will have a project manager, which will do the initiation, planning, monitoring, and support. We'll have an application engineer, which will do the system configuration, analysis, and sizing. A manufacturing engineer, which will operate the scorebot, do the programming, and present the demonstration. And a sales engineer, which will do the documentation and the proposal presentation. It's competitive, and there will be bonus points given to the winner in each one of the subjects, which will be tested in the presentation. We will develop a solution for an automated cobot process. We will develop a simulator with a scorebot to this solution. We will write a proposal, and then we'll present the solution. The example of the project that we'll be doing is taken from a real case which was presented by a company in Automate 2017. Here is a situation where we have an operator which does testing, another human operator, which feeds a set of machines. We have an input conveyor, an output conveyor, and the objective in this particular case, using a UR10 cobot, is to replace this human operator with a robot that will work in tandem with one operator. Parts will be coming in on an incoming conveyor. The human operator will present it to the robot. The robot will pick the part and present it to one machine. It will also circle the parts throughout all the other process machines, and when the part is done, it will be placed in front of the human operator. Human operator will test it, and then if it's good, it's going to be placed on an output conveyor. If it's not good, it's going to be rejected. So that's a sample of a project that we'll be doing, and we'll talk about the specification of this specific project in the lab area. In the remaining of this presentation, we'll talk about introduction to robotics project management, and we will try to apply some of the principles in the final project. When we look at the robotics solution, it is typically related to 3 main characteristics of the product that we try to present to a customer. One is the cost of the engineering as well as the product itself, the quality of the performance, and then the time that the product is going to be developed. And we have fast, cheap, and good. We can only pick two. The other one is going to be dependent. If we are looking for high quality, the cost is going to be higher. If we're looking for high quality, the time will be higher. If we're looking for low cost, then the time is going to be lower. So these are interrelated relationship between cost, time, and quality, and we could only trade off among them. We cannot enforce the three of them, mostly. The characteristic of robotic solution is that it is interdisciplinary, so project team typically include mechanical, electrical, manufacturing, and software engineers. It requires a seamless engineering, teamwork, and it is managed in 4 phases: initiation, planning, execution, and completion, as we'll see them in more detail. The ingredients of a project process success depend on knowledge, on skill, and on attitude. And knowledge pretty much is the know-how that we learn throughout our career. Skills is the hands-on experience that we have, and the attitude is the characteristic which we bring into the project as a team member. As a team member, which one of the three is the most important to project success? Well, it's not knowledge and skill, it is an attitude. And the reason why it is an attitude is because in a fast-moving environment, such as a project, attitude, as we see here in the Blue Angels, is everything. The project management objective and task is to meet specified customer needs within defined time, within agreed upon funding. And again, the management task, project management task, is to orchestrate the planning, organization, motivate, and control. The project manager is a leader that has to go through planning, execution, and closing. And as we see, Walt Disney in his statement has said that of all the things that he has done, the most vital was coordinating the talents of those who work for him, in leading them into the certain defined goal. The folks which are interested in a project that we get involved are the customer, the project sponsor, the management, the project team, and the project manager. In our simulated case, the project manager will be selected. The project manager will work with the team in order to assign goals and do the planning. Management in this simulation is myself, the project sponsor is the university, and the customer in this case is a virtual customer that we try to satisfy in providing them a solution to the defined project. Project management typical timeline is that initiation takes about 10%, planning and execution takes about 80%, and completion takes 80%. However, in many cases, the first 90% of a project takes 10% of the time, and then the last 10% takes 90% of the time due to, in most cases, change requests that come in throughout the project. There are several ways of running a project. The traditional way is a waterfall. As we see over here, we go from requirements to design, and then implementation, and then validation, and then completion. And then we have over here concurrent engineering, which is more up-to-date type of project management style, and that is we are working in iteration. We go through the planning requirements, analysis, design, and deployment as soon as possible. Then we test the first version, we evaluate it, and we go through the same cycle again and again until we finalize within the timeline the product that we like to do. Of course, the testing is not done on a complete system. It's pretty much done in order to validate, show feasibility, remove knowledge gaps. The cycle that we see in the development phase for the initiation, planning, execution, and closing. In the initiation, which is typically a pre-sales, we understand the request of quotation of the customer. We do qualification analysis, we do system analysis, we do feasibility testing, and we write a proposal. This will be the objective and the task that we will be doing in our short-term project in this course, and we will be planning the real project and present it in a proposal. And the planning includes starting with the PO, organization, task scheduling, cost estimation, procedures, and kickoff. And then the execution includes feasibility testing, preliminary testing, detailed design, procurement, assembly, integration, and testing. And then we close with documentation, ATP, which stands for Acceptance Test Procedure, signed by the customer, and then shipped, installation at the customer, and then ramping up to from prototype to full-scale production. As we see over here, as Werner von Braun said in '72, one good test worth 1,000 expert opinions. Throughout the process, we like to, in a concurrent engineering plan, do and check, continuous cycle, test, test, test. The approach that we may use in our presentation when we are in competitive environment, we are competing with other teams, we are trying to get the job. It could be of several types. The traditional way is shown here with the red curve. These are the sales effort. This is the time. And then in order to get a purchase order and so-called beat the competition, the customer first has to know us, they have to like us, trust us, then they may come to the conclusion that they may have something to that may be good for them, and they have to validate that it will work for them, and then they compare it to all the other competition and conclude that it's the best, and then they say, let's buy. This is a pretty long process. It can take from anywhere from weeks, months, sometimes big projects, this process will take a year. And an alternative approach, which in the last few years it was originated by a few folks from MIT in Boston, and they came up with a process that is basically called a provocative approach or innovative solution approach, and it's shown over here in the blue. And although we may be coming out of the blue and not be known, they after we show a presentation which is innovative, in order to differentiate ourselves from the rest of the competition, the customer may say to itself that we never thought about that proposal option, and then they have to convince themselves that this unique proposal is going to work, and we usually do this by validating it with a proof of concept feasibility test in laboratory, such as we'll be doing in the project. And then once we prove it and convince the customer that we can do it, they may make a decision to take a prudent risk and go ahead with our proposal. So the key here and the idea that when we compete, we would be in a better position if we differentiate ourselves, and if we differentiate ourselves, we most likely will have to have something innovated. And of course, to understand the need, which is 50% of the solution, as many people who are experienced in projects will tell us, then we have to know the customer good, and we have to talk to them directly. There is a risk involved in any one of development of a new product. It has never been done before. If it's a prototype, and then we saw Warren Buffett says that risk comes from not knowing what we're doing, and the sources of risk may come in from many directions. In order to mitigate that, we should be doing system analysis and feasibility testing. One backs up the other, including throughput, precision, control strength, gripping, cleanliness, noise, magnetism effect, life and reliability. Testing and analysis will help us mitigate the risk. The go, no-go decision for the project are typically done by, first of all, willing to take a prudent risk. It's not a wild risk. It is a risk that any new development has to take if you want to progress, if you want to compete. And we need to assure a strategic fit to the corporation strategy. We have to validate the customer competency to work with this technology without initial more time spending in closing the gaps. We like to provide a differentiated solution, maintain sales margin, and from my experience, 1 man year of engineering assignment to development work typically needs to be justified in production by $1 million per year. Otherwise, it may be rather difficult without other reasons to justify getting into a prudent risk product development. From my experience, a solution proposal template should be, as Leonardo da Vinci said, simple, since simplicity is the ultimate sophistication. It has to be organized and have the key elements for the customer to make a decision. We have here 9 elements. First, we present our understanding of the customer needs. Then we nicely list all the specifications with the assumptions if some of them are missing. Then we present a solution configuration, mechanical, electrical, and software. We conduct system analysis on this configuration. We also do component sizing, and then we do price quotation for all the components. We have the cost that we allocate for them, plus the markup, and then this adds up to the price quotation. Then we do the scheduling to finalize the project. We also list the acceptance test procedure that the customer would know what is expected of him to sign off at the end of the project, and then we conclude by presenting the customer the values of working with us. How much will it cost? There are many factors, including material, labor, engineering, consulting, rework, travel, outrigging, shipping, crating, and capital equipment. We should consider all of these contributions. It is important that we make a sales presentation to so-called sell value, not parts, simplicity for high reliability, complete solution for one-month stop if we can, low risk for feasibility with feasibility test results, flexibility for changes. We don't want to limit the customer to its original specification. We want to open the door for possible changes. We want to sell leadership in the work that we do, and we want to avoid selling dollars. The planning, as Benjamin Franklin says, if we fail to plan, we are planning to fail. And if, for example, it is known that to build a house, it takes 6 months to go through the design, 3 months for bidding, and 1 year for construction, and it takes 2 years. The question is, if 10 people could build this house in 1 year, can 100 folks build this in 1 month? Can we add more resources to the project and get it done faster? Well, the answer is no, and the reason is we see here a PERT, it's Program Evaluation and Reporting Technique, that shows all the tasks that has to be done and the milestones. And there is a critical path which takes the longest. And we see that if we add more people, they will not be able to do much unless the folks which are assigned to this path complete it. Because in order to go into this action item, all of these 3 must be completed. So if this is the one which is being delayed, they will be sitting idle and rolling thumbs. Now, if, as shown over here, an example from the literature, that there was an initiative to build in China the tallest building in 90 days. And then after everything was done and settled, the project was canceled. And the reason is that there was no need for it. So when we go through the project, we, at least on a management level, we want to make sure that the project represent a solution to a real need. Because we spend resources in order to develop a part, we want to make sure that this part will actually expand, and other than the prototype, it will ramp up to full-scale production with quantity to justify the investment. In the planning process, we have to answer questions like what has to be done, who will do it, how will it be done, when it will be starting, when it will end, what is the risk involved, how we mitigate the risk, how much it will cost, and what to do, what do we have to do now. So this is part of the planning. And the scheduling tips that we get. And by the way, all of this information is taken randomly from the internet, collected, pretty much grouped in order that I experienced with, and we thank all the contributors for their contributions to this presentation. Then some of the tips is that you can accurately plan the details of nearby tasks. The people that do the work must be involved in scheduling. People that are assigned to the job, they have to like what they do in order to be successful. Plan the project for short iteration, test as early as possible. Take the requirement-based approach and keep the eye on the requirement pool. Schedule the task involving external groups. Remember to include the training in the process of skill set which are missing, and choose an approach which fits the environment of your corporation. What has to be done? Many actions have to be done, and they're listed in a work breakdown structure, including feasibility test, configuration, analysis, component sizing, design, reviews, critical design review, preliminary design review, cost accounting, procurement, assembly, testing, documentation, presentation, and commissioning. And we will see how this is typically being listed on a Gantt chart. When does it start and when does it finish? It depends on past experience. We estimate the time by the resource that is doing the work. We don't impose it on him. They have to agree to that time. Competence level of the resource will also reflect on how long it takes. Cushion has to be always included to provide room for changes. Clarity of the input of the task will also help minimizing the time. The difficulty of the task is also involved in the time and the frequency of milestone. If we have many milestones, it will take a longer time than if we have one milestone and try to focus on it. Whenever we think of task assignment in a work breakdown structure, we want to make sure that we are smart, which means that we like to have specific tasks, measurable, attainable, relevant to the job, and time bound. Here's an example of a Gantt chart. You could Google Gantt project and download that for free or for a $5 contribution. And you see over here the breakdown structure of all the tasks. And then you have the time starting, the time end. You can expand that and also see the resource. And over here you have milestones and you have the different tasks, how they working along the timeline from beginning to the end of the project. Here's an example of SAP Corporation Material Resource Planning tool to come up with the cost estimation of the project. Once we have the bill of material over here and all the design is completed, we can go to the cost estimation, and this is taken from Festo example project. And here we have the third-party material. We have service costs, we have in-house material. All of these costs has been allocated over here, and then the bottom line with the gross margin here shows and reflects what will be the price that we quoted to the customer. A kickoff discussion when we're ready to roll includes a statement of the initiation document, stakeholder who is involved in the project, customer statement of work, specification list that everybody in the team should be aware of, the Gantt chart with all the breakdown tasks listed for each one of the resources with a clear milestone, risk list that is known to us and how we plan to fall back if we hit it, and then communication policy, and then reporting policy. The item related to assure that when we do action, then we keep the eye on the ball, is to use proven components as much as possible. Try innovative solution in order to assure the differentiation in a competition. Back it up by system analysis to reduce the risk. Use reference web experience. Write work instruction. Use standard operating procedures. Sketch the options. Brainstorm pros and cons. Think of the complete manufacturing process, and always conduct validation tests in a concurrent engineering process to assure that you are heading in the right track. What are the risks involved? They are not meeting the performance, not meeting time, not meeting budget. The resource availability may be missing when you need it the most. Customer all of a sudden may make changes, There may be insufficient information to complete the task, or wrong initial estimation, and also job cancellation. It's not uncommon. The execution, reference, and work documentation also include customer statement work. We obviously will not use all of them in our course project, but some of them, like the Gantt chart, will be there, and the customer specification, and also statement of work. And then also the change request should be done in writing. Action item list in regular periodic reports. We'll see an example. Progress reports, which the project manager hands out to the team and to the other folks who have interest in the project. The preliminary design review document, critical design review, acceptance test procedure document, and then the customer acceptance document. The changes in the project are the major cause of job delays. Anything that can be changed will be changed until there's no more time left in the project to make any more changes. Here's an example of a weekly action item list. Using Excel tool, you see the action item number, and this is the phase which was initiated at kickoff, and these are the action required. For example, rapid prototype part. This is the resource that is assigned to it, the day that it started, the priority is high, and then the routing of this information, some comments, and then from one discussion to the other, it is by the project manager determined if the action item is still open or it is closed. So this is an example, again, taken from Foster Corporation. The execution skills that we would like to have team members bring into the project is positive attitude, motivation to succeed and win, monitoring everybody's own work as well as project managers, the team's work, adapting quickly to change requests, well communication procedures, a problem-solving attitude. If there is unexpected problem, the attitude is not to complain, but to try to solve it. Risk mitigation, decision-making process under uncertain environment, and reporting techniques. And again, Will Rogers says that even if you are on the right track, you will get ran over by an object if you are just sitting there. So we want to make sure that we are continuously moving. How does the team member value their own job? Well, 20% of the people typically do 80% of the work in a project. However, 80% of the people think that they are these 20%. The reporting activity, as we mentioned earlier, include milestones, executive reports to stakeholders, weekly meeting reports, test results, supply chain reports, risk mitigation status report to stakeholders, and troubleshooting progress reports. And these reporting, we want to make sure that they don't consume the project. For completion of the project, there is typically a closing checklist that includes the system test results, documentations including bill of materials and manual, spare parts lists, summary reports including ATP test results, customer acceptance sign-off, and also we have customer action items in order to ship the system. It's many times part of the process of completion. And then the change request, invoicing, if it's agreed upon, and then project closing notification. This concludes our presentation. We will continue with the definition of the course projects in the next lab, and we will dedicate 3 lab sessions to finish up the project. Thank you.